Welcome to the Sleep Science Podcast Christmas Q&A session. We've got lots of exciting questions from our listeners, and we've got a panel of sleep experts from the NAPS Sleep Lab in Cardiff who are going to introduce themselves now, and then they're going to answer all the questions. So take it away, Holly.
Hi, I'm Holly. I'm a PhD student in the NAPS lab, and I study a technique where we play sounds to people while they're deep asleep and hopefully try and improve their memory using this.
I'm Jen. I'm a research postdoc looking at the intersection between sleep and epilepsy.
Hello everyone, I'm Thomas. I'm a second-year PhD student in the NAPS lab using mathematical models to understand the relationship between sleep and memory.
Hi, I'm Sophia. I'm a postdoc researcher and I'm interested in the effect of sleep on abstraction.
Hi, I am Mo. I'm a third-year PhD student and I am working on using machine learning to identify memory reactivation in sleep.
Hello, I'm Viviana Greco, a second-year PhD student in the NAPS lab at Cardiff University. I'm mainly interested in sleep creativity and emotions, and currently I'm investigating the effect of sleep on insight problem solving, and particularly I want to see if sleep might help us to overcome cognitive obstacles that prevent us to think outside of the box.
Hi, my name is Martina, and I study the relationship between sleep and memory as well. I look at the effect of reactivation on structural changes in the brain.
We also have three fantastic interns. They've been producing all of the podcasts and they are going to read the questions and even answer some of the questions. So do you guys want to introduce yourselves?
Hi, I'm Dominic. I'm an intern here and I'm also producing this episode.
Hello, I'm Sophie Smith and I'm an intern in the NAPS lab and I've been working on the podcast and helping out with studies.
Hi, I'm Annie. I'm a former intern in the NAPS Sleep Lab.
So shall we start with the first question?
So our first question comes from Jenkins, and she asks, why do we use the term sleeping like a baby when babies don't in fact sleep?
The first thing I'd say is that babies tend to sleep around 16 hours a day, which is generally twice as much even as a good adult sleeper. Normally the conflict comes, and why we think that babies don't sleep is because they don't sleep at the times that we want them to sleep. They sleep during the day when we're active, and then in the middle of the night they want to get up and party and eat and do all sorts of things when we just want to sleep. And part of the reasons for this is when we're first born, our brain is not fully sort of connected up. All of the different areas of our brains are not wired to talk to each other yet. So there's a part of our brains that is known as the master clock. So it controls our circadian rhythms. It tells us when we should feel tired in the evening and when we should get up in the morning. And then there's a part of your brain that is involved in actually going to sleep, staying asleep, and waking up. And these are two different areas of the brain that need to talk to each other for us to feel sleepy in the evening, go to sleep overnight, and wake up in the morning. And in babies, scientists in the US have shown that these two areas of the brain can't talk to each other yet. So at least until you're 3 or 4 months old, these two areas of the brain don't actually have connections between them. So babies don't have this urge to go to sleep when it gets dark and wake up when it gets light. They just follow all their other kind of urges. They'll wake up when they're hungry or sleep when they're tired. So I think that's where we feel like babies aren't sleeping, even though actually they're getting way more sleep than any of us.
Beth Lee would like to know, how do hormones affect sleep? Because she's been pregnant and now menopausal, and she's sure that they do.
So Beth is right. Sleep disorders are so common in menopause that they're considered to be one of the main symptoms of menopause. Just to get an idea of how common they are, there was a study in the US looking at a survey of 13,000 women that were between 40 and 55, so either right before or right after menopause. And they found that the rate of sleep disorders jumped by 25% when women had menopause. So it's very common for that to be affected. And sort of the main hormones that we think about at play are estrogen and progesterone. And both of them are implicated in sleep disturbances, but estrogen is a little bit clearer. The role of progesterone is still a little trickier. So estrogen cycles through the normal menstrual cycle, and it's very high during ovulation and low during menstruation. And then it's even lower still during menopause. When we sleep, one thing that happens is that your core body temperature drops, and that kind of lets you fall into deeper and deeper stages of sleep. Estrogen has a key role in keeping the temperature of your body low while you sleep and regulating it. So when you decrease the estrogen, it disrupts the temperature and the cycle of body temperature during sleep. So there have been several studies looking at body temperature just at different stages during the menstrual cycle, and just the normal cycle between ovulation and menstruation have shown that there is about 0.5 degree Celsius difference between the two stages. You're warmer during menstruation, and then in menopause, when your estrogen is lower still, the core body temperature rise can contribute to hot flashes. So it makes sense then that your temperature regulation and your ability to fall asleep are sort of linked together like that. And one upside of this is that it means that estrogen therapies can really help, and there have been a lot of promise showing that estrogen can improve sleep.
Our next question comes from Christopher Reynolds, and he wants to know, why do some people talk in their sleep?
Unfortunately, just like in the case of many scientific questions, we don't have a clear answer to why. What we do know is that genetics may play a role, because there have been twin studies confirming that. And just like other parasomnias, which are abnormal behaviors during sleep, they tend to run in families. And also, we know that some environmental circumstances and factors can trigger sleep talking episodes. For example, emotional stress, certain illnesses, alcohol consumption, certain medications, or sleep deprivation. Physiologically speaking, the speech and motor areas get activated in the brain during sleep. So that's what's happening. That's why one talks in their sleep. It is not classified as a mental illness, so no treatment is required. And proper sleep hygiene and following a regular sleep schedule can reduce the symptoms. It is quite a common phenomenon. The estimated prevalence rate ranges from 5% to over 50%, depending on how the given studies classified it. And we also know that it can occur during any sleep stage, so it might be non-REM or REM sleep.
A question from Lauren Finaldi. Is an eye mask effective for better sleep?
That's a great question, and we also were really interested to see if the use of an eye mask during sleep would have been beneficial for sleep quality and cognitive performance as well in healthy adults. For what we've seen so far, wearing an eye mask is particularly beneficial during the summer months because we are exposed to early morning light that might disrupt sleep and waken people up. So specifically, to investigate the potential effects of the use of an eye mask, we asked people to perform a word pair task that requires to learn 80 semantically word pairs in order to assess the clarity of memory. And we have surprisingly seen that blocking the ambient light had a marked effect on subsequent learning performance. What does it mean is that it is possible that the use of an eye mask might impact upon aspects of sleep quality or sleep microstructure that in turn lead to a better subsequent encoding. Moreover, we also asked the participants to perform a psychomotor vigilance task, a well-known measure of sustained attention, and also demonstrated to be sensitive to sleep deprivation. This task basically requires participants to focus on a cross in the middle of the screen and then to respond as quickly as possible to a millisecond counter that randomly appeared on the screen. So when performing the psychomotor vigilance task, we noticed that people had faster reaction times associated to the use of the mask, and reaction times have a significant impact on different aspects of our lives. For example, we can think about driving or playing sports. So overall, faster reaction times allow us to efficiently respond to stimuli. Therefore, we can say that the use of an eye mask during periods of increased natural light in the early morning can produce significant benefits.
So Lauren would like to know, can meditation before bed help you have deeper sleep?
So this is a very interesting question, and there have been lots of studies over the past decade that have looked at the impact of mindfulness-based interventions on insomnia and sleep disturbances. These interventions include meditation, for example, but also other interventions. There is now substantial evidence to support that meditation is effective in improving subjective sleep measures, such as self-reported sleep quality and insomnia symptoms in various different populations. However, when these studies have looked at more objective sleep measures, using, for example, polysomnography, much smaller effects were observed. So at the moment, it is still not clear whether meditation can actually change our sleep patterns or simply our perception of our sleep patterns, also known as the metacognitions related to sleep. So the other part of this question is related to timing. So whether or not meditating right before bed would help your sleep. And the main model that explains insomnia today is the hyperarousal hypothesis, which basically says that the more people focus on solving their sleep problems, the more difficulty they will experience when falling asleep or staying asleep. So for this reason, when these studies are done in the lab, the researchers strongly advise against using meditation to try to sleep, and instead they ask their participants to practice meditation during daytime. So in short, to answer your original question, meditation can improve your subjective sleep quality, but at the moment we have no evidence to suggest that it will help you have deeper sleep. And by that I mean spending more time in slow wave sleep or REM sleep. And ideally it should be practiced during daytime rather than right before bed as a strategy to fall asleep.
The next one is from Laura Bojarskaite, and she asks, why do we need to cycle through different sleep states multiple times per night? I.e., why isn't the first half of the night slow wave sleep and the second half REM sleep?
Okay, so this is an interesting question about the structure of a night of sleep. The real answer is we don't really know, but we have lots of ideas about this. So we know that REM and non-REM sleep are physiologically very different states. So that means that you have a completely different cocktail of neurotransmitters running around in your brain during these two different states of sleep. And your brain activity is also very different during these stages of sleep. So non-REM sleep is associated with high amplitude, slow oscillations, whereas REM sleep is associated with actually quite wake-like looking activity in the brain. And what we know as well is that these two different states seem to have very different functions in terms of what they actually do for memory and also what they do for our physiology. And so all of these things combine to suggest that instead of just having all of one and then all of the other, it may be important to interleave these two different states together. So you have a little bit of non-REM and then a little bit of REM and then a little bit of non-REM and a little bit of REM interleaved again and again across the night. And that may be much more effective, both in terms of influencing memory consolidation and in terms of benefits to your physiology, clearing toxins from the brain, etc., than if you had them in two great big lumps. You can think of it a little bit like annealing metals, where you need to heat the metal and then cool it and then heat it and cool it and heat it and cool it. And you get a much stronger metal out at the end of that than if you just heated it once and cooled it once. So sometimes you need to iterate between different kinds of processes to get a strong result. There's a second thing I can say, which is that unlike REM sleep, our desire, our need for non-REM sleep builds up across the day of wakefulness as a kind of a hunger. We call it sleep need. And you can literally see as people get tired, this need for non-REM slow wave sleep building up. And so that's why they go into non-REM slow wave sleep first. Early on in the night, it's like they're starving and they need to satisfy this hunger before they're willing to spare any time for this less hungry REM. Maybe you can think of it as kind of a dessert type phase of sleep. That's possibly not quite fair, but it's satisfying a different need, and that need is not as strong as the need for non-REM sleep is. So this could also be something that influences why you get first non-REM, and then maybe you get a little bit of REM, and then you get more non-REM, and then maybe a little bit of REM, and you go back and forth like that until you've satisfied that need for non-REM, and at least you don't need the deep, slow wave part of non-REM anymore. So that's the second part of the answer.
Suzie would like to know, how can we remember dreams some nights and other nights nothing at all?
So a prominent model I found reading up on this is called the arousal retrieval model. And it hypothesizes that there are two steps necessary for recalling a dream. For the first step, the authors say that a certain amount of cortical arousal is necessary in order to transfer information from short-term memory to long-term memory. and a period of wakefulness should follow the dream experience for the person to recall it later, because without this wakeful period, consolidation processes don't take place. And once the dream is stored in long-term memory, comes in the second step, the retrieval of the memory. Here, researchers find that the salience of the dream content and interference that might happen during the wakefulness period, such as an alarm interfering with our awakening, greatly impact our ability to retrieve the information. But generally speaking, the more salient the dream and the less interference is happening as we're waking, the higher probability that we'll be able to recall dreams. The way researchers like looking at this is basically waking people up in different parts of the night. And generally speaking, the more nocturnal awakening and the lower your sleep quality, the higher the chance of you remembering your dreams in the morning. And actually, when those awakenings happen also seems to matter. So, for example, in one experiment with healthy adults, researchers found that people who were woke in the REM stage of their sleep had 80 to 90% chance of reporting a dream, whilst people who were awakened in non-REM sleep only had 40 to 50% chance of reporting a dream experience. There's a lot of other things that researchers were looking at, such as emotionality. So, for example, I found that if you're experiencing lots of stress, that can increase the chance of you remembering your dreams, although there seems to be a gender effect. So stress actually increases dream recall frequency in women, but decreases it in men. For example, there was an interesting study on that. Generally speaking, we'd also find that the longer you sleep, and if you sleep at home where you regularly sleep, that also increases the chance of you remembering your dreams. Yeah, those seems to be the most important factors as far as state variables are considered.
Okay, our next question is from Brittany McCabe, and she asks, what exactly is happening during sleep paralysis, and why does this happen sometimes?
So sleep paralysis is the kind of phenomenon, it happens as you're falling asleep or as you wake up, where you're awake, but you can't move any of your muscles. And it can be really quite scary. Sometimes people have visual or auditory hallucinations at the same time. For most people, it happens once or twice in their lifetime. It's not associated to any other kind of disorders in their sleep or any other issues. Some people have it a lot more often. There's some idea that what's happening is different areas of your brain are at different stages in the waking up or the falling asleep process. So part of your brain that is controlling your sort of conscious awareness is more awake than the part of your brain that's controlling keeping your muscles relaxed during sleep. And so you have this disconnect where you can't move any of your muscles because that part of your brain thinks you're asleep, so you shouldn't be moving your muscles. But the sort of more conscious part of your brain is more awake, so you are experiencing this when you kind of shouldn't be really, you should be asleep.
So Veronica is asking, do animals dream?
Freud, in his famous book, The Interpretation of Dreams, asked the very same questions, basically just writing, I do not myself know what animals dream of, and then moving on. But it's still on people's mind, probably because they see their pets twitching and sometimes running in their sleep. I believe in 2019 there was a viral video of an octopus sleeping, and his owner was speculating that it might be dreaming about catching a crab because of the way its color and texture was changing during sleep. We cannot know if other species have the same mental experiences as us, but to the extent that their physiology or behavior overlaps with ours, we can infer certain parallels in their experience. It is important to note that we have good evidence of REM activity underlying dreaming in humans, but it's not a sufficient condition for it to occur. A lot of people never report having a dream when woken up from REM. Other people report dreams even when they're woken up from non-REM stage. Some other people frequently report having a dream experience without actually being able to specify this experience, something that's been called a contentless dream or a white dream. This is only to highlight that the neurophysiology underlying dreaming isn't even well understood in humans, so we're not in a good position to judge whether animals have it or not. If we take a more developmental evolutionary approach, it's been known for many years that mammals and birds possess REM and non-REM sleep, and more recently, lizards have turned out to have both. So one could argue that the common ancestor of these three groups of vertebrates already had both sleep stages, and that would mean that it's been around for more than 300 million years, potentially suggesting that all these animals could be dreaming.
Nisaya Kulia would like to know, are all of your senses still activated in sleep?
Absolutely. Processing of sensory information is definitely present during sleep. Sound, smells, light, and some sensory sensations still reach our brain cortex when we sleep. They are dimmed, that's for sure, and not always reach our conscious perception. That's why we sometimes miss our morning alarm, for instance. However, our brain still, consciously or not, with or without waking us up, picks up all that information. So in the end, hopefully, more often than not, we do wake up to an alarm or with the sunlight. It's an important evolutionary adaptation that on one hand keeps us safe from potential danger, but on the other allows us to get a decent amount of sleep without waking us up on everything happening around us. You would, for example, wake up more readily to your name being called as compared to someone else's name, or to a baby cry, or to noise or smell signaling potential threat like fire or thunderstorm. And light, on the other hand, plays an important role in regulating our circadian rhythm, the internal clock that tells us when to be alert and when to rest. It hinders melatonin production and a sleep-promoting hormone. That's why it's so important to make it as dark as possible during the night to promote sleep. And the fact that our senses are indeed active during sleep is important from a research perspective, as it provides the basis of a technique called targeted memory activation that we use in our lab. So our participants would come to the lab and do a memory task, say, attempt to remember a couple of words, and each word would be associated with a distinct sound. We would then replay these sounds to the participants during sleep, effectively reactivating the memory of some of the words. Even though the participants are not consciously aware of the fact that we played sounds to them during the night, the next day, when tested, the reactivated words are remembered far better than the non-reactivated ones. And that also works with smells and with other tasks, and has been used in many other labs, not only to improve memories just for the sake of improving them, but also to learn more about the reactivation of memories that occur spontaneously during sleep with no external triggers, which is the basis of how we remember stuff. So a short answer to your question is yes, all of our senses are still very much active during sleep.
John Nickel is asking, can you fall asleep faster when you listen to white noise before bed?
So there are actually some studies showing that listening to white noise can help you fall asleep. It's not necessarily just listening to it before you go to sleep, but kind of starting to listen to it while you're lying in bed trying to fall asleep, and then having the white noise maybe continue on for a while you're asleep. This does help people to sleep in noisy situations. Like there have been experiments in hospitals, and that has been shown to help people to sleep through the noise, particularly if the white noise continues playing all throughout the night.
And that's a wrap for the Sleep Science podcast for 2020. Many thanks to our listeners for their questions and their continued support. We'll be back with a brand new season in the spring. Meanwhile, feel free to get in touch via Twitter at #SleepSciencePodcast. From all of us here in the NAPS Lab Cardiff, have a wonderful holiday.
Merry Christmas.